today we're going to cover Apache Airflow, and we're using this for an actual project that it's an all-volunteer group. So the context is that we are studying drugs for cancer therapies. And this is an all-volunteer group, as I mentioned, and it's a cross between biologists and computer science types. In this computer science realm, we have analysts, people who are really good at visualization and dashboards. We have machine learning people who, data scientists, they're prototyping algorithms that are using larger data sets. Traditional computer scientists, I'm personally myself a web developer, so from the web application side. And of course, we have a strong need for data and data infrastructure, and so that's where Apache Airflow is going to come in. So let me go ahead and just introduce a little bit of the premise of the Apache Airflow. So it is allowing you to programmatically author, schedule, and monitor workflows. So of course, we're talking about data flows. The fundamental unit is going to be the directed acyclic graph. These are DAGs. It's a mathematical concept from graph theory. We'll get into it in a second. But it's there to define task dependencies and execution order. We also have operators. These allow for a variety of integrations and just allow for easy integrations that are just easy to customize. You enter a few parameters and you're integrated with your Amazon S3 bucket or a bunch of other ones. It's based out of a web interface, so there is ultimately, from a data engineering perspective, UIs are very helpful because they help to oversee a large orchestration of data. There's a lot of files and scripts and tables, and everything's just massively scaled. So user interfaces are your friend, and even though we're programmers, you kind of reach a point where when you're dealing with complexity, the UI help, and that's one of the functions that Airflow is giving you. There are behind-the-scenes schedulers that are allowing for the execution of these workflows. And then there's just a large set of integrations, databases, cloud services, all kinds of tools. So I wanted to start with kind of the foundational concept behind the Apache Airflow. And as I mentioned, it is coming out of graph theory. So there's the directed acyclic graphs, and they consist of vertices and edges. I mean, this is kind of the concept. It's not critical, but to understand the terminology, but the concept behind it is important. It's just this idea that you have a flow between states, and that those flows are connected with these, these arrows or these edges, and that each flow in this case is a data processing step. Now, if you look at the terminology here, directed means there is ordinality to the direction, meaning there is a flow to it. Acyclic, A meaning not, so not cyclical. So there is a not cyclical flow to this data. And so basically any graph is an acyclic graph as long as there's no loop that could cause an infinite kind of circle. And of course, that makes sense logically. You don't want data sets feeding into data sets, for infinity. However, you can build large forward networks, and that's the real concept here. So these are all going to be tasks. These are all going to be things that are put into the data workflow from a perspective. So taking it a step back in another way, we have the data sources, and then you're doing orchestration. That's really where the Airflow comes in. It's in a class of other tools. It's not the only one. We like it because it's open source, it's extensible, meaning you can add add-ons, integrate with things very well. It's free. It's a good price, but it's just one of a set of tools that does this process, ultimately leading to some kind of outputs. These might be the ones over here on the right might just be data storage, long-term data storage. But you see that the things that you're kind of doing are in the realm of ETL, that's extract, transform, and load. These are very common operations. It's really arbitrary what you're actually doing. These could be notification systems. They could be cleanup, cache management. There's a lot you could do, but conceptually, these are very common workflow for what you're using Apache Airflow for. I want to put this talk in a very specific context where when do you use it? Because we will get into the code and we'll get into like the tooling. I speak for myself as a programmer, and I just want to dig into the code and kind of get going with it. But Apache Airflow fits a very specific part of the ecosystem, and you have to really understand the needs of your project to even know if it's the right fit, because a lot of times it's not the right fit. Most of the time it's not the right fit. It really is fitting in a specific part of data engineering, and generally at a project scale where you're working with a team. I can't really think of why you would need to run this as a solo developer unless you just have large data dependencies, but it's usually a team context. So we look at the premise of data engineering. Cloud, of course, you just infrastructure. It happens to be what you integrate with because it's cheap, it's affordable, and it's just big. But it really comes down to visualization, that very next bullet point. This idea that you're doing something with the data, you're informing. This could be a graphical information. It could, however, also be a business insight. Should we merge with this company? In our case, with the drug discovery, it's should we use this drug for cancer, right? And but there's some kind of insight or business logic that you're driving. Visualizations are wink, wink for me, like an output. We're kind of over here in this platforms, infrastructure. There's a lot of things that run compute, that do processing, data movements, data analysis. There's a lot in there. There's your raw data stores. These could be existing buckets. They could be open source projects. I will point you to a few of the ones that we're using in our cancer research scenario. But basically, it's either your data, somebody else's data, but you have lots of it, and it needs to be processed and structured. And then, of course, the bread and butter of analysis, the R, Java, Scala, Python, just working with it. But we're talking really about a large project, right? And so the large project here, you probably have a team where you might need a dedicated data engineer. So, we're kind of on the volunteer side, kind of stepping into that. We don't, strictly speaking, have a dedicated data engineer, but if you did, they might be doing nothing but Airflow scripts and data hygiene processing. So a little briefly over here on the side, data quality is king for business or scientific insights. Data breaks silently. That should be a nightmare situation for you. Break silently, and the data is always dirty. That's the norm. So life is hard. You have to process your data. And that can, in fact, be a full-time job, especially in a variety of contexts. The role of the data engineer there is to support a team in a predictable and actionable way where they can generate insights. This is really a focus on infrastructure. And then when I talk about business to data translation, what I'm saying is that you as the data engineer really have to understand what's driving value for your business. It's not enough to say, I cleaned the Excel file. Well, what did the Excel file do for the CEO lately, right? You have to be able to translate and understand every department, every, cross-functional team that you're working with. You have to understand what the value lies in the data. And this is non-trivial, and this is can and should be a full-time job to really, you're the king of your data, but you're also the king of the business analyst position, understanding how you're driving data for the business. So Apache Airflow fits in here as a tool for a specific type of project, but it is in the context of ultimately providing value for either a business or scientific endeavor, and you really have to have a clarity on how the data is adding value, because it may not be worth using Airflow, and in fact, there's so many tools, as we'll get to in just a second. So I wanted to reinforce that by, I think when you're in this data world, the world's changing so quickly, and there are so many platforms. We're over here in workflow and data ops, but there's data processing, there's SQL databases, NoSQL, other kinds of databases, data lakes, MI platforms, analytics and visualization, and metadata. And it's easy to feel lost. And what I want to kind of get at is there is no right or wrong answer. I'm not here to sell you Apache Airflow. I'm here to give you the context of when it would be useful. But there's other ways to do it, and there's no right or wrong answers, as long as you tie it back to the value for the business, right? As long as you're getting actionable insights. And to get through actionable insights, you have to go through dirty data to clean data, to comparisons and analysis, to aligning with business strategy, to doing the work at an insight, selling the vision. You have to present the stuff, and then executing a change in what you're doing and making a decision to do something about it. And so we're over here in data management, but again, you have to tie it back to what is the value for the business. So understanding what drives value is critical, and there are no standard team structures, tools, or outputs. I'm not here to say that this is the only way to use Apache Airflow. This is our way, but there are guiding principles. Go for transparency, add value along the way, always have safety and security, governance in mind, and always keep the business and scientific merit of what you're doing in mind at every step. So I want to look at this and think about, we're over here. You see this Airflow is kind of this middle infrastructure between data sources, and we have teams that we're working with, right? And so what I kind of want to emphasize here is that these are actual people that I am working with on my team that, for example, I have data scientists. Well, the ecosystem for data scientists, where they're doing AI, ML, and data modeling, they need access to data, and they need access to clean data, but they also need transparency at the data. One thing about AI is that you don't need to pre-assume what the useful dimensions are. The training data will have the features in there. You need to have enough features in your data to be able to make a good classification, but it's going to be they're going to need access to data that maybe you forgot to expose, or maybe it's what they need is a step above this raw data, right? So keeping in mind at each place in this process, the engineers, the scientists, the analysts, which again, the analysts are doing the visualization work, Tableau dashboard, to really connecting with the business value in particular, but really fitting us the Airflow in a way where you keep in mind who the users are. So my users are, in fact, analysts and data scientists. And in practical terms, because I'm a cancer research group, it's biologists, right? My no-code biologist PhD friends never want to look at a database, never want to touch a line of Python, but they need to get value out of this Airflow investment. And so making sure that I'm connecting the narrative of how I'm using data is going to be really critical here. So let's go into a few of the specifics on Apache, and we'll kind of circle in more and more on our scenario as we go deeper into the code. but these are the basic concepts of the infrastructure in the Apache Airflow. So like when you install Airflow, what do you get? You get a web server. Now this is a Python. I don't actually know how to say this. Unicorn, I'm not sure, but a G unicorn. It's the Python web server, and it's going to, again, providing your UI access. I'll show you this a bit later in the demo. But it's all of your DAGs are there, all of your data pipelines. Scheduler, daemon responsible for scheduling jobs. So, you have to have, it's very similar to a cron scheduler. You have something executing on some interval, but there has to be a master overseeing the execution cycle. Data Metastore is just the Apache Airflow's own database. It's where what's important here in the Metastore is this is where you're storing probably the connection and credential strings for all of the things that you're integrating with. You don't want to have your connection strings in the code. That's actually not good security practice. But you do have it somewhere, and that place is going to be in this database that comes along with the Apache Airflow. The executor is the thing that is actually running these. Well, it's defining how the tasks are executed, and the worker is actually running the tasks. So again, I wanted to spend a minute to ground this conversation in a real works instance. So I want to talk about my situation, and I'm going to actually switch out of slideshow for a second to show you this planning document. What this is my rationale as a project manager for why we need Apache Airflow. What does it mean for us to need a data orchestration tool? Why are we doing this? And it comes down to we've reached a level of complexity that we just literally cannot do the kinds of data processing that we need as a team without a higher order of integration. So I'm going to start down here and say the concepts here are not important. It's the flavor that I want to give you. But basically, we have an existing data process. We have a data set that we're working with right here. Happens to be called Prism, and it's giving us this raw data. And the fundamental algorithm that our group came up with was processing this data to give us some kind of results table. The light blue here are these final output tables, and then that lets us do some kind of actionable business insight. So I'm putting in the salmon color this. These are the outcomes. So I'm able to predict something about cancer based on an analysis. And this analysis has to do, in our case, with compounds and how they work with tissue samples. This is all just straight from a single data source. But we need to take our analysis further now. So we have compounds and how they work in a data source, but we don't have enough information about these compounds. So now we need to bring in another data source. This other data source happens to be called Guide to Pharmacology. It's connected with this Hugo group, and it brings in physical chemistry and aspects about compounds. This compound has this structure. This compound binds with these proteins. These proteins have this relationship to these genes. And it's kind of like lateral information that was not part of our original study that we can really greatly benefit from. Specifically, if we can already tell you which compounds do well for what cancer, but we can't say why. To answer why, this really beautiful scientific question, why did something help with this tumor, we need more information. And there's two approaches that we can do once we get all of this glued together. One of them is statistical, right? One of them is like, what compound sets, if you look at compounds by category, the categories for us, for example, are what compounds target what protein. So for example, MEK inhibitors. MEK is a protein. It's a signaling pathway that relates to growth of the cell. And for tumors, that especially the ones that we were looking at, if you can inhibit this one protein, you can specifically target the growth of tumors. And by the way, leave normal cells largely alone. And so we realized that this category of compounds was something we were fascinated by. And we want to answer this question, well, what are the other categories? Right? Again, we don't have that information. So we need some kind of infrastructure where we can do higher order statistical analysis. These are things like clustering algorithms. Another algorithm that's pretty cool is straight up machine learning. Can we do a classification? Seeing what features from a bunch of data sources. So now we're incentivized to bring in tons of other data sources. There's another data source over here. It's totally unrelated, has gene information. Can we bring that in? And what's being proposed here is a way to do this with a data warehouse. So the data warehouse is a central nexus. It's the combination point for all of the data sources. So it is an intimate relationship, as I'm proposing it here. It's an intimate relationship with Apache Airflow. Where does the data flow to? Flows to our data warehouse. Now, it's not the only place you can, like, again, this is our scenario. There's other scenarios where, maybe it goes to a Snowflake instance or all kinds of other things. But this is our scenario. Now, along the way, as we're building out a data warehouse, we're setting up some conventions that I just want to briefly call out. We have source tables, source tables, intermediate tables, and final tables, right? And the reason that we have intermediate tables is that maybe machine learning needs access to higher order information than raw data, but lower information than the finals. Like if you have a final, maybe you've summarized or averaged, but then you lost track of the original data point. Well, somewhere you should have a table that has the original data point, because some statistics and some algorithms need that raw data. And so there's this kind of premise in data warehousing of store everything because you don't know where you need it. The other thing I want to call out for the rational and context is look at what else we can integrate, non-standard data structures. So these are knowledge graphs. And then another thing that our group is particularly interested in is something called network pharmacology. And it's just network information. It's basically graph information again, related to how do genes relate to each other? How do compounds relate to genes? It's a bunch of relationships information. And that obviously answers a huge practical biological question for us. How does a compound relate to a gene, relate to a network of genes, right? And by orchestrating data at this higher order of complexity, we can answer more rigorous scientific questions. And so we have motivation and justification for the investment it takes to have a data orchestration tool. So I have that here. Future work will allow us to integrate with advanced statistical and AI approaches. So while I'm here, let me talk through a scenario that involves, what we're actually doing in an Apache Airflow. This is like a conceptual justification for why would our team need Apache Airflow. Well, if you look at what we need to do, we have our raw data. We need to load it. We need to run our calculations, and then we need to generate that connection to cancer. And by the way, we have this other data set where, the guide to pharmacology. And so you can see where Python would come in. Python comes in as a step that allows us to do a translation along the way. But ultimately, you need to be having a need where the type of data flow, if it is complex enough to justify an investment in a more robust tool. I would tell you what, if it was just this one sequence and we were done with it, don't do it. You do it in a script, do it in Excel, do it as a one-off. Don't invest in Apache Airflow. But if you have sets of these things where in context, where you have a lot of data sources and you're asking higher and higher order questions, higher dimensional questions, then yes, then Apache Airflow is your friend. And in particular, if again the team complexity merits it. So let me just go back to the team for a second. The concept that, you know, how can I also empower a data scientist? Well, they need access to the same stuff that I need. How do I empower the Tableau person? Same data, right? And they don't, each of these end users needs not just the raw data, they need that derived, you know, post-processed data that may be very advanced, maybe involving 4 or 5 data sets coming together into something actionable and useful. And that again, going to be project to project. All right, so let's get into the infrastructure. This is of the Airflow. This is not a install or infrastructure talk, so I won't spend much time here, but I do want to call out some key details. And one of the key details is when you go through the install, it's really important as the server administrator to realize that there is an Apache Airflow CLI command line and that you should be using it. There's just a few things here. What I'll show you as a quick demo is just giving you the flavor of what you can do. So I'm going to clear this. So I'm logged in as my user. You don't need to install this as root. I didn't need to. You shouldn't need to. Don't use root. But in any case, I'm a user, and I'm in my Airflows directory. Actually, doesn't matter where you are because Airflow is just a standard command. And if you just type it with no context, then you get a list of all the commands you can run with it, including this cool cheat sheet one. So, you know, I want to make you aware that there is a CLI interface, and it's actually really critical, especially when you're getting set up. But it can do cool things. It can list your DAGs. It can list your connections, all kinds of stuff. There is one process that actually I'm showing on this slide right here for how I actually start my Airflow. This is something I will profess that my Airflow installation is not perfectly production ready yet. We're still, you know, we're a small team, and you know, I didn't invest too much time here. But this is what I'm doing, and you know, feel free to investigate better ways to get this going. But essentially, it comes down to I'm starting a scheduler, which again is a daemon. It's this -d daemon for running the background scheduling of tasks, and then getting your web server going. And I wrap this in my own script, which is just run airflow.sh. Again, this is just by convention how I do it. Again, the contents are just these 3 lines, but just I want to point that out as it was very helpful for me to have just like a one script like launch the server, because again, it is more than one thing that's running. And in fact, there's actually another one that we can run as well, which I'll show in a second. So the other thing I want to point out is that when you install to a port, that there is a /health to check the health of your server. So let me go ahead and open that. And what this is, if you're unfamiliar, this is a JSON. It's a JSON string, and it's pretty printed, so you can kind of read it. And this should show you a few things. It should show you what's healthy. In particular, it needs to return. So if you know about like developer codes, it should return a 200, meaning successful request. If it doesn't, your server's down. Specifically, your web server's down. Additionally, you need to have at least your scheduler running. You'll notice that there's also a triggerer. I don't use triggerers in my project, so that would be like another daemon that you might need. But I've found it that most cases I can get away with just the scheduler. You do need, of course, the metadatabase. That should always be running as well, and that's just a connection to you know, whatever database you set up your Apache Airflow with the first time install. But these two need to be running, as well as just the fact that you have a health. Always start by checking this. I've noticed that airflow from my production environment's been a little bit buggy, can go down. So not a big deal. Let's go ahead and restart it. I do think there are production ways to improve that. But this is not an infrastructure talk. But I will do one other infrastructure segue, which is pointing you to the airflow config file. This is where all of the config of relevance is, and most importantly, it points to a folder saying, where are your DAGs? DAGs are ultimately going to be Python scripts, and where are they, right? Okay, so here's where they are. The other major setting that I happen to change, just so you're aware, is the default port number. I'm not using the default port number. I think the default's 8080, and I'm using 8088, so don't let that catch you off. That was proprietary or custom to my setup. But in any case, you can do stuff like that. What are the defaults? Where are the DAGs? All kinds of other stuff that relates to, is this Kubernetes? Is this sequential, running these like just locally on your own infrastructure or what? So yeah, that's what I wanted to point out with that. Let me go into full screen again. All right, so let me actually start with just a basic Python. Like let's just like crash into a script, right? So that we can start to get familiar with it, because we'll start to see a lot of patterns and repeating. So the first thing is that what I have here is I'm writing a DAG file. This is my reference DAG. Because I'm working in a team, first of all, I have onboarding information, so I'm documenting what my data warehouse structure is. I'm also documenting what the DAGs are doing. Don't expect code to be sufficient in these kind of contexts. Talk about the data sources, talk about the business intention, talk about the scheduling cadence. All that stuff should be in a wiki or a knowledge base to supplement the code. Things get very invisible very quickly in these large data projects, so you need good documentation. But in any case, we're just importing Airflow. Right now, Airflow has a huge ton of these convenience functions, and you're going to see this all over the place in this tutorial. But for example, our Python operator, that's going to be something that we encounter very soon. We're setting up some defaults. Not too complicated. A start date, a number of retries. We're fundamentally giving the DAG a name. That's this line 15 right here. What is the name? It should be a unique ID. Now this is a scheduling cadence. This is kind of like if you've ever worked with cron for scheduling on a Linux server, but it's basically a syntax for, is this running once monthly, weekly, daily, hourly? You can also, in this configuration, it's manual. At once means manual here. So we're triggering it. I'm going to skip ahead a little bit to actually the bottom, where this is where you set up the ordering of the DAGs, like what flows into what. So what we have here is there's a start, there's a middle, hello task, and an end. If we go ahead and look at start, it's just a dummy. We're actually not using it for much. It's just a placeholder, really. We are using this hello task, and what is it doing? Well, it's calling a Python operator. It has a Python callable, which is just a function, right? So we are basically able at this point, at line 22, this is our arbitrary Python injection. Like line 22 is where you put your arbitrary code. In this example, you're off in your own world doing whatever you need to do to get your data transformed. But in any case, that's run, and then you have the end operator, which is just here. Let me take a segue into the actual view for this. So let me find my reference DAG. Let me reload that. So I do sometimes have some glitches on the UI web server. Again, I'm not super set up with that, but it's good enough. All right, so this is our DAG, right? Start, hello, end. This is accessing it from the web interface. If I went too quickly, what happened was, here's the home. It lists all of your DAGs. You'll notice that when you install the basic, they give you a bunch of like educational ones, and you can just delete those. Those don't matter too much, but they are a good reference. Eventually, you'll have ones that you turn on that will be your main. Just because they're turned on doesn't mean they're running. It really depends on what the scheduling is. If they're automated scheduling, then yes, they'll start to run relative to your start time. But in any case, here's our reference DAG. I'm clicking into it. There's a graph view, and what I think is really cool is you can actually click in and see the code view as well. So, you know, if you're like, what was that thing again? You can actually just click into the code and, oh yeah, it's a thing that prints hello world. It just does some, you know, trivial arbitrary thing. And we'll get into that in a little bit more detail. But I just want to give you a sense for what we're doing is we are creating Python files that define what a DAG is, and that becomes something that you are executing against. Now, as far as being an administrator on this site, I do want to show you a few of the other things. There are ways to set up Apache Airflow to have lists of users, and we'll get into this in a bit, but there's also a way to set up all of your connections. So like I have a Postgres connection. I think we'll get into that in a second. But in any case, there is some UI admin level stuff. There for the users, there is the you know, you can make them an admin or a user. So there's a bit of granularity. But the main thing you're doing is probably logging in and checking on the status of your runs and a few of those details. So let's go back now to talking just kind of conceptually about what we're looking at again. So now this should start to feel familiar, right? So I'm on the code on the left. This is another Python operator, right? So we have one operator here, one node, and it's just calling a Python callable print hello, which is just going to be a function up here. It does something. Okay. We gave it a name. So in this case, the name is example Python operator. That's the name of the DAG. And it's very simple. So obviously, I'm biasing this as a Python talk. So I'm going to spend a lot of time talking about the Python operator. It's my favorite operator. But what are operators? So operators are Python classes that encapsulate logic to do a unit of work. They can be viewed as a wrapper around each unit of work that defines the actions that will be completed. And they abstract most of what you need to write. When you create an instance of an operator, it provides it with all the, what you're doing is you're gluing in the parameters. So if you look at the example of a Python operator, what do you need to run a Python something or other? Well, you need to point it to a Python function. So that's Python operators are very simple. All they're doing is you kind of have a, it's kind of like object-oriented design. You have a class and you're just filling in the default parameters. And that's basically what the operator is doing. Now these operators, there's a ton of them, right? So there's bash operator, Docker operator, email operator, generic transfer, JDBC, which does a lot of the databases, but Microsoft ones, Redshift, Slack, and these are just like the built-in ones. There is a huge open source community of other operators. And these are going to be, think of them kind of like recipes or templates. Like they're giving you, they are a Python class, and they're giving you access to something that you can just use right away. So again, the one that we're focusing on is the Python operator, but there's also a Postgres operator for interacting with databases. We'll get into that example specifically, but like remember that you're setting up a template or a recipe, you need to pass it parameters. For a Python operator, that parameter is a function. For a database, you actually need credentials to log into the database. So you have to pass in some kind of connection information. So the operator parameters are going to depend on what the operator is, but conceptually, it's a class, and you're saving some code by just using it as a template. Just as far as another terminology, airflow sensors, there's a lot of terminology in airflow, and I would say it's a weakness of the project. What I'll also say is that most of the terms don't matter that much, and need them when you need them kind of thing, like learn them eventually, but you don't need them from day one. Like what we're covering in this talk is basically what you need to get started. But I do want to call out airflow sensors. They're a special kind of operator that can happen when something happens. So, for example, you could actually monitor for a change and then trigger something when it happens. It's kind of like a monitor. And so, for example, you can monitor a table, and if a value in a table changes, then you run the operator, right? And so that's what these sensors are. They're conditional, and they're waiting to execute downstream tasks based on some kind of thing that they're looking for actually happening. All right, so you might have noticed at some point that we were passing in the default arguments for a DAG. You can kind of see right here, a DAG is being created with some kind of name, and we're passing it in some default arguments and some time interval. What are these default arguments? Well, let's just talk through them top to bottom real quick. I'm going to use the graphic over here on the left. Just an owner, like who is this? Who's this affiliated to? Depends on path. It's whether the instant depends on the previous task's status. So for example, if the last thing failed, should this run? Yes or no? Start date and end date are very interesting. So start date's kind of intuitive, right? When should this be started to come into play? So you can kind of envision that, like, say that it's about to be the new year, and on the new year, you're changing data systems, right? You're going from MySQL to Postgres, this big data change. So you want to pre-program your DAG. You can pre-schedule it, have it be live, have it turned on, but you don't want it to start yet. So you can go ahead and pre-populate when the start time will be. It will then follow your prescribed interval. You know, there's somewhere else you're saying, is this manually run? Is it run at a daily minutes basis? And you can do that. It's kind of related also to the end date. End date is very interesting. When would you use an end date? One of the instances you might want to think about is this doesn't always have to be for future case data. One of the things that you might want to do is kind of play back the last year's worth of transactions. So you could actually schedule, a slot of interactions and kind of run that set of data. And so that's where the end date kind of comes in. It's not a common one. You're generally not using it, but that's where you would use it is if you're kind of modeling a certain type of information. Now, email on failure, email on retry. These are notification systems. There are some plugins that also do notifications. It's best practice to have emails on failure. You want to know when your data breaks. You want to know very loudly. I wouldn't count on just this, by the way. I would have multiple points of triggering and failure and post upload validation. You know, sanity checks. Manual sanity checks and automated sanity checks. You really have to be paranoid with large data systems. But, you know, having something built in that just emails you if a pipeline failed, very nice. Retry, obviously, how many times to retry if it failed. So maybe you tried to connect to a database, but the connection was rejected because it was oversaturated. You know, when do you try and how do you try? That kind of stuff. I'm going to skip the queue and back pool and all that stuff, but they're kind of they're relevant for distributed systems and systems where you have larger stuff, or again in those weird situations where you're working on backfilling information, which is that scenario of like going back in time. Now, There are other parameters. So like these are the default arguments for the DAGs, and these are parameters, but there are other ones. And I want to just point out this link, check it out in your own time. I've shared the slide deck on the meetup comments, and I'll, wherever I post a video, I'll have it there too. But callback parameters. So these are something that you can also add to your DAGs. So on success, callback. On failure, callback. Callback is a programming term generally meaning a block of code that you get to later at the end of some kind of event. So obviously on the success, run this callback function. It generally means you're passing it a function. So do this thing if you fail, do this thing if you succeed. You don't need to use these by default, but if you have advanced usages, it's nice to know they exist. SLA. SLA is a term that they use a lot in the Apache. If you've never worked in an enterprise context, SLA means service level agreement. And what's implied here is generally when you have a service level agreement, it's a commitment to do something in a specific amount of time. So, you can define how long this should run. This task should take an hour. If it's been 12 hours, then that's a problem, right? You missed your service level agreement. And that's what this callback would be, is you've to set up some kind of time expectation. It's missed the time expectation. So you have an opportunity to do something interesting. And there's a bunch of other ones. All right, so connection credentials. This is what I want to circle back to. As I mentioned, it is not good practice as a coder for you to say, hey, here's my database password. Let me put it in my Python script. This is a bad design because it means that you can't share your version controlled code, right? It's bad for a lot of reasons. What if there's you didn't mean to commit it, or you forgot? Just all kinds of reasons. But in any case, there is a way to set up a connection credential, and the most important part is going to be this connection ID. I'm actually going to show you this briefly. So as an admin, I can go into the connections area, and I have here my Postgres, right? And so I have a connection ID. We have the Ollie credential. It does have the password, but that's in the database side, so it wouldn't be shown on the UI. But we do have all the other information that we need. And the most important one is this ID, because in the code, this is actually what you're referring to. When you make a connection, it's going to be a connection to a string. Let me go ahead and show that so that we're making an understanding there. So this is going to be another very simple example. And it's just, it's a test of the database connection to the data warehouse, DWH, data warehouse, and create table if it doesn't exist, okay? And if we look at what our tag is doing, again, it's a start, a middle, and an end. We'll look at the middle. We'll say, oh, look, it's running this, it's called DW test task, and it's calling a Python function test table create. Let's go to test table create. It's going to try and do something. So now we're connecting to our Postgres. If you look at the Postgres hook, Postgres, the hook, the term hook here is basically a connection. I know hook is used in different ways in different languages. My understanding is it's basically like a connection. And it's this idea that you don't want to have the credentials. I don't want this developer to have the password. But what they can do is they can refer to a connection that does exist and just cite it by ID. So that's a better practice. So now I have a hook, and I'm able to use this hook in my Python operator, and it's giving me access to my database. All of a sudden I have my cursor, and I can execute the primary activity of this task on my connection, on the whatever I'm hooked into. So that's great. That's kind of the vibe that you're going to get with all of your connections. You're going to set them up ahead of time. It's not up to the programmers don't want to spend time. Oh, does the connection work? What was the login password? Set that up ahead of time and just give them a string that they can use. That's what you're connecting to, and then they do the stuff. So again, it lets your data people focus on data, less time on infrastructure. And that's what I wanted to point out. But actually, the other thing is just what the options are, because I like that kind of stuff. So these are some of the defaults: email, FTP. There's a file path, generic. It says if maybe it's something you can get from these Airflow provider package. Again, that's one of the reasons why Airflow is actually kind of nice, is that you have a large open source community. So a lot of other integrations already exist, or they're easy for you to create, in fact, as well. BigQuery, Cloud, HTTP, of course, IMAP, pip, Postgres, SMTP, like for sending and SQLite. So again, if you didn't see the one you want, you can add it. It probably already exists. Somebody's probably already done it, but this covers a lot of bases. And it's just this idea that you're setting it up in the UI as an admin ahead of time, and that the person who's using it doesn't need to be an admin. Like you could have just a general entry level data person come in and start to use things without having to worry about that orchestration or that kind of securities perspective. All right. So yeah. So here's where I believe I'm going to switch over to the code. What I want to talk you through is a loose example. And I'm going to say this is loose because it's not it's not fully refined yet. I'm still working on this, but I wanted to give you the flavor, because I think for your purposes, the flavor is enough. So let me narrate the scenario here. So I am doing biological data, right? And I mentioned that I have an external data source, and that data source exists right here. It's Guide to Pharmacology. I've already loaded it. It exists as this massive resource. It's 224 tables. It has more things than my little, brain can comprehend as far as biological information. I love it, though. I mean, you need somebody on your team who speaks biology, and you need somebody on your team who speaks SQL, and ideally they're the same person. I mean, these cross-functional skill sets are, of course, more important than ever. But even when you don't, at least what I do have is I have some people on my team who can solo this, and then I have other people who I've paired them up, biologist and a database person, to be able to run this. All right, let me double check that I have connection. I should. View first 100 rows. Okay, yeah. So it doesn't matter. I have connection. All right, but yeah, there's a lot of information here. And previously, I had an intermediate table created in the Guide to Pharmacology. This was before the data warehouse got built. So there's like a historical reason why it's not in the data warehouse already. But it comes down to this ligand list. Ligand are compounds, and they're like the things that we're fundamentally testing. Do they help with cancer or not? So this data source doesn't have the answer of does it work for helping with this tumor or not. But what it does have is a lot of information about what the compound is. We have, its formula, its IDs, a bunch of other things. So we're interested in it because it has a lot more chemicals in it than we have access to. Well, it has all the ones that we have and more, I should say. Now we're over here also in our data warehouse, and we're just trying to move things into our data warehouse with this understanding that we're trying to build a statistical analysis between what are the compounds doing and what are the results for a given compound. Those are kind of like merging two entirely different data sets into one analysis, but they need to work together at the data warehouse level. So let's take a look at kind of some of the code thinking, at least some of the thoughts behind that. And this, again, work in progress. But what we have here is a set of functions. So let's kind of take a look at the DAG, right? So we're going to start, it's going to be our dummy operator. We're going to extract, load, and combine. I believe we need to update that. We'll take a look. In fact, I know we need to update that. We need to start by getting the data, right? So the data, one of the scenarios here is that I have a list of compounds, and let's say what I'm trying to do is merge it, or I'm trying to create a unified data source. So I'm selecting both of these from, in this case, the Guide to Pharmacology data set. So again, materialized view, which by the way is a Postgres concept. It has to do with basically like a summary table. It saves you time when executing other kinds of queries. But this is something that we have access to. And so this already exists in the Guide to Pharmacology database here, and it gives us this ligand list. So again, let me just show you what those values are. Again, you have to always be on track of what the data is. Fundamentally, it's a ligand ID, a name of a compound, and some supporting information about it. Synonyms, species, other stuff doesn't matter too much, but those are the main ones. Now, what our goal is to be able to answer the biological question, what made this compound successful in this tumor? And one of the ways that you can answer that is by knowing what the shape of the compound is. What is its shape? What is it doing at a chemistry level? Well, guess what we have in our data set, again, in the Guide to Pharmacology, we have ligand physical chemistry. Physical chemistry has to do with, how many hydrogen acceptors, and it has to do with things like, is it more like an oil or more like a salt? Does it dissolve in water or does it dissolve in oils, right? And it's this idea that we know information about the compounds by we know information about the compounds, and we later, as a post-processing step, we will do that statistical analysis. But the very first thing we need to do is join this supportive information, that has to do with the physical chemistry with our primary list. So we're getting our primary list, we're getting our physical chemistry. So let's skip ahead to the extract data step. So this should look a little bit familiar. We are calling a Postgres hook, right? These are all Postgres connections in this case. Didn't have to be, could have been other database. In this case, they were. And I'm not calling it with credentials. I'm calling it by a unique ID. This is the unique ID. I set this up ahead of time. Now, what am I doing with it? Well, I'm executing a key function in the extract data methodology. And so I'm actually extracting two datas. I'm extracting all of ligand list and all of the physical chemistry. And again, there's multiple ways to do this. This is just a conceptual way. And we're returning a tuple that has both of those data results. And we're going to use that. If you imagine where we are in the database, we've extracted information from a source. We're intending to move it to the data warehouse. We want all information in the data warehouse. So what I'll do here now is kind of step backwards. I mentioned that we were missing some steps, and I think what we need to do, extract task, define extract task, extract task calls extract data. right, which extracts data, load task. Okay. One of the things that we need to do is we're going to create an output table. It's going to come down to um, creating a new table in our output database, and let's just work through some of these. So one of the things that we're going to do is we have to create net new tables, right? This is dynamically creating tables. It would have been different if I had hard-coded these, but I'm not hard-coding these. I'm dynamically creating table entries. And what I want to do is I want to capture the information about what these columns are from the source connection to the target connection. So that's what this function is doing abstractly. We are selecting column names and data type from the schema information, from the kind of metadata about it, for the table that we're looking at. And we're creating something. We're creating actually a SQL script. So this is actually dynamically generated SQL. Create table, where we're basically recreating what we saw into this new thing. So let's generate SQL. So that's being called here in this create tables. Create tables, we're creating two tables, one table relative to that ligand list and one table created to that model view controller. So where we are in the processing is basically extract. We are extracting information from the sources, moving them into the data warehouse. Not yet done, elegant post-processing. We're just getting it out so that we can play with it in our arena. But that's what we're doing. So we now have SQL that represents this arbitrary table creation. Again, it's dynamic. And by the way, this is like largely ChatGPT. So just use ChatGPT. It'll, we're not opposed to it. It's really good at these really atomic task generation. So, I can endorse it. It does a pretty good job. So we're going to go ahead and create those tables if they don't exist, commit and close, all that stuff. So that's being called here in our create tables. We're going to move to a load data perspective. And when we are loading the data, so now we're connecting absolutely to our data warehouse. And we're going to want to do an iteration through our data. And it's going to come down to this insert into table. There's table 1, table 2. We kind of saw that, here, create table 1 if it doesn't exist, create table 2. These were the intermediate tables. And we're just inserting the data, right? It's not very elegant. It's just doing that. Later on, we'll do a combine. So the combine task, which comes kind of at the end after the tables are populated, what they will do is this union. The union is the key word here. Create table if it doesn't exist, combined table, select star from target table 1 and target table 2, these two dynamically generated tables, and create this new table out of that. And so that's what we're doing, is we are doing a glorified join, getting information both out of a reference table and into a new database, and then going through intermediate tables, presumably to a final table or into a secondary intermediate table, whatever you need. But that's kind of the flavor of what's going on here. Is we're setting up some kind of execution order. These can branch, they can be conditional as well. You can do something, if this completed, then do this, else do that. It's absolutely possible. But this is to give you a flavor of, using Python operators in particular for the data extraction, working with databases. I like the best practice of having the queries up here, so you very quickly know what's going on. And again, there's a graphical perspective. Now, when you go to run these, let me show you running these things. We'll start with our simple. We'll start with the test DAG, which was creating intermediate table. At any time, there's this trigger button, right? So you notice that in a lot of mine, I don't use scheduling. That's a choice of our project. But what I would do is I would just click the trigger. It runs for a bit. You can actually see the status populating over here. It will go through each step, turning green if it's success, yellow if there's issue, and kind of completing. And then, again, you get the view and the event log, and there's some cool things. What I want to also show you is a failure. So this is running the other one, which, again, is this start, extract, load, combine, end. And just to give you a flavor of what this looks like. So we see where it got in the process, start and extract. So it got through some progress. It's definitely choking on load. So, I can now look at that, let me go back, failure, and it's over here in logs, and you do get the stack trace, right? So you can go in, you can troubleshoot and do all that. I want to show you, by the way, what I think of as best practice. This isn't open to interpretation. It's not a strict part of this talk, but what I recommend you do, because the password's not in the DAGs, is I recommend that you use version control for your DAG. So let me show you around the DAG infrastructure one more time. So let me go ahead and log in again. Here we are. All right, so there exists an Airflow folder where I installed all this stuff. And there exists inside of that a specific place. You'll recall that I put this in the configuration file where the DAGs folder is. Doesn't matter where it is, but you just pick one. I'm going to go ahead and change directory into that. And what I have inside of that's actually the folder that I had configured, which is this nf airflow DAGs. This is a Git repo. So cd nf airflow DAGs, git status. It's a Git repo. And what I have as a producer on my side is I have a repo that has all my reference DAGs in it. So we'll go over to, let's do our test DAG data warehouse. What it's currently doing is using the comp bio and create table if it doesn't exist, delete me, and then I'm just gonna say let's create another one called new table here. All right, so at this time I've written my elegant master task to take over the world, and I'm ready to get this going on the Apache Airflow. So I'm going to do git status. Oh yeah, there's some changes. Git add all my changes. Git commit, and give it a useful title. Updating the test DAG example. Push it to origin. Git push. Now, how you want to do code review is up to you. I am running a very narrow team where I'm not going to have code review before this goes to the server, like not very deep code review. But this would be, for example, when you would want to do a code review. So before you deploy your DAG that deletes your database, have somebody review the commit and make sure that you're doing a merge, and you have a formal process. We're doing it kind of informally here. So okay, now updated, it exists. Okay, so what I do, so you can set up automated deployment to your server. I'm keeping it dirt simple. I'm just going to do a git pull. So git pull, I'm just going to pull the code down myself manually. There's my changes. So at this time, what you would want to do is go to your DAGs. If you added a new one, you'd want to go ahead and refresh. There's this refresh button here. It will look for your things. By default, it will not be active yet. It would be in your inactive. But we previously set this as active. But let's go ahead and take a look. We should be able to validate that the code is updated. Yep, new table here. Go ahead and run it. We'll see how it does. Going from green. All right, we got full green. Let's check our data results. This would be over in the data warehouse table. We're looking for the creation of a new table, and then there it is, new table here. So success, we've done a data operation, relatively trivial here, but you can get the point. You have arbitrary control. And again, if it was just simple things, do it with a one-off script. Really, the value is that we are able to work at a higher order of complexity. I do want to show you some of that justification, though. I think I'm, yeah, let me show you some of the justification here. So why would you need this? I'm going to bring over another data, bring in my data source. So if this is a real world situation, real world data, so I have cancer's data, right? This is one of my data, it's not even all of them. It's just one data source out of 50, like it's an enormous number. It's, it's all work, But anyway, depth map, whereas it's a data source, is actually a data set of data sets, right? So, okay, so there's multiple data sets. What's really important here is that look at the versioning that they're using, right? And so, okay, I'm using some of these files and they have versioning. So when I build this infrastructure, if you think conceptually about what I need to do to support dynamic data, not even streaming data, but just data that updates maybe once a year, well, if I didn't have a GUI that I could just go to and click, hey, rerun all the data pipelines when this one file updates, because this is the bottom of the pyramid. All the derivative data is based on this data. So if this updates, there's maybe 30 or 40 different dependent tables, tasks that are based on this, and I can orchestrate that as a pipeline. So now I am incentivized in this very complex project where I know predictably that these data files will be updated at some point in time, even if it's not all the time, but I know that it will happen often enough that it would be a huge inconvenience for me to forget how to create all the derivative tables. And in fact, if I create it as a DAG, then I just have to click one button every time my source data changes, assuming it follows a similar schema. And boom, like all of my derivative information is updated, perhaps more accurate or larger in scope. And that gives me, long-term stability and a growth perspective. So again, I wanted to make the point that Apache Airflow comes in not necessarily for small problems. It comes in for team level, long-term, high complexity, but the value you get is security, knowing that you can recreate higher dimensional derived data sets to some degree. You can have lots of notifications. You can automate a lot of the scheduling if that is a relevant feature. And that it just integrates with a ton of things and just makes your life really straightforward. There's a ton of convenience libraries. We kind of only covered a few, but there's Postgres, Python, and Slack, and all these other ones that are very convenient. And so that gives you an ecosystem you can grow with. All right, so with that, I think that's the end of my formal presentation. This repo is in the slide deck. You guys can take a look. I'm adding to it all the time, so it's a very active part of my project right now. So again, take a look at that. It will continue to grow over time. And what I'm talking about is this one right here, the NF Airflow DAGs. Just gives you some reference. You'll see my reference DAG in there just to get started with. If you have any questions at this point, I guess let me get my chat open and we'll kind of get into some of that. All right, if you could, I guess, raise your hand using the hand raising feature. If you have any questions. Karan, if you could unmute yourself, please.
Hi, can you hear me?
Absolutely.
Yeah, no, first of all, thanks for that presentation. That was really good. I just had one quick question around dependencies. So one of the reasons why my team and I have actually moved away from Airflow in the last few months over to Dagster is that there's certain packages that we can't use the latest version of. One that comes to mind is SQL Alchemy. So I just curious if you've faced that problem, that challenge, and how you go about sort of like dealing with that out of curiosity.
Thank you. I wouldn't say that you can't use SQL Alchemy. I would say that if you look at the structure of the interception point, like technologically, there's no reason that you can't. Now there might be, like I'm not sure as far as like all the libraries and dependencies. There's always a way to make it work, right? So I'll just give you a very case in point. This supports Docker pipelines. So if you truly had some weird edge case where like there was strict conflict in some operating system, just Dockerize it, and you can have whatever sub environment in that Docker, right? So there's always a technological reason why you can in fact use Airflow, but I'm not necessarily strictly advocating Airflow. What I actually recommend you guys do is look at other things like Dagster, and there's a few others. They all kind of follow similar methodology. I don't know if there was a more advanced technical reason that you had a conflict, but conceptually, it theoretically shouldn't be an issue. You have the ability at the point of your script. If we take a look at the point of your imports to import arbitrary things, right? It's your arbitrary Python by the time you get to the hello world, right? So if you want abstraction at that point, there's some of that. I'd have to look deeper at SQL Alchemy. I think I see what you're saying as far as like the class level integration. In that case, I'd have to see if SQL Alchemy has a binding with Airflow. If you want to work, because for those who don't know, what Apache Airflow does, lets you work with models, classes that represent tables. I don't see any reason you couldn't get it working, but I can see your point as far as if it doesn't exist yet, that would be a challenge.
Yeah. From what I see from the issues logs on GitHub and stuff, it's like they kind of like waiting for version 3. So it works version 3 of Airflow to make it compatible with version 2 of SQL Alchemy. But right now you're forced to use V1 like of SQL Alchemy on Airflow. That's the one drawback that comes to mind. There are other couple of packages as well, but yeah, that's just the one that comes to mind. So, but no, that's still really, really useful. Thanks again. That was a really good presentation.
Oh, absolutely. My pleasure. Let me open it up. Are there any other questions? If you could raise your hand, please. Going once, twice. All right. Thank you so much, everybody. Have a wonderful evening. Again, the slides are on the meetup comments. Check those out. My email is on the first slide. Reach out with any questions. Good luck on your data journey, and let's solve a lot of the world's problems. Thank you. Bye-bye.